Hello friends and welcome to your channel GATEquestionsECE. So the next question in this series of random variables is having question code 119. Consider two independent random variables x1 and x2 such that x1 is uniformly distributed over interval 0 to 3 and x2 is uniformly distributed over interval -1 to 1. If z is equal to maximum among x1 and x2, then find the PDF and CDF of z. Probability that maximum among x1 x2 is less than 2 and expectation of z and variance of z. So we have done a similar question which was question number 118. In question number 118, x1 and x2 were distributed over interval such that both intervals were non-overlapping type. You can see here that x1 is distributed from range 0 to 3 and x2 is distributed over interval -1 to 1. So this interval is common between these two intervals. So let's see how to handle such problems for z is equal to maximum among x1 and x2. So let's first write what is given in this question. So it is given that x1 is uniformly distributed over interval 0 to 3 and x2 is uniformly distributed over interval -1 to 1, and also x1 and x2 are independent. So it is a case of independent random variables. So we can write the PDF of x1 for sample value z will be equal to 1 by 3 in range z greater than 0 less than 1 and 0 otherwise. For all other values of z it will be 0. So the CDF of x1 we can write will be z minus 0 upon 3. So that will be 3, z by 3 in range greater than equal to less than equal to 3 and 1 for z greater than equal to 3, and for all other values it will be 0. If we plot these, you will get like this. So from 0 to 3, here it should be 3. Its value is 1 by 3 and its integration will be like this. So the CDF is like this. It is 1 above 3 and 0. So this is the PDF and this is the CDF of x1. Similarly, we can write for x2. Its PDF is 1 by 2 in range -1 to 1 and 0 otherwise. So we plot it. It will be like this: -1 to 1, 1 by 2. So the CDF of x2 will be z minus -1, so plus 1 divided by 2, and range -1 less than equal to z less than equal to 1, and 1 for z greater than equal to 1 and 0 otherwise. So if you plot it, you will get diagram. It will be a rising line, straight line, then afterwards it will saturate to 1. So from -1 to 1. So we know from our previous discussion that if z is equal to maximum among x1, x2, where x1 and x2 are independent, then the CDF of z is related to the CDF of x1 by this relation. That is, it is product of x1 and x2 for same sample value small z. So all we have to do is find the product of these two CDFs. So we will have to product or multiply these two CDFs. So you can observe in the CDF of x1 that for values of z, so this is z axis, values of z which are lying below 0. So for this range of values, CDF is 0. So this CDF is 0 for z less than equal to 0. And anything multiplied by 0 will be 0. So we can write that the CDF of z will be, for z less than equal to 0, it is certainly going to be 0. And for z greater than equal to 0, let's see what is the CDF. So you can see for z greater than 0, it is non-zero here. And similarly, in this range, z greater than 0, in the CDF of x2, you can see it is also non-zero. So you can see from 0 to 1, in both of these CDFs, in 0 to 1 range, they are having same behavior. So we can write that 0 to 1, it will be the product of these two CDFs. So expression for the CDFs in this range are this and this. So we will take product. So that will give z by 3 times z plus 1 by 2. So this is the expression for the CDF in this range. Similarly, we can find out for z greater than equal to 1 and less than equal to 3. So you can observe here, it is a straight line in this range, but this CDF for all values of z greater than equal to 1, it is 1. So 1 multiplied by this with CDF for all values of z greater than equal to 1 will be this CDF. So we can write it is equal to z by 3 in this range. And for z greater than equal to 3, it will be 1. So this is the expression for the CDF of z. So let's try to plot it. So this is our z-axis, and this is going to be the plot of CDF of z for sample value small z. So for z less than equal to 0, this is 0. So below 0, it is 0. And above, from 0 to 1, you can see it is going to have a scaled function. So 0 to 1, it will rise up to this point, a parabolic function in this range. And from 1 to 3, so this is 3, in this range, it is a linear function. It will be a straight line between these 2 points. And afterwards, it is a straight line with value 1. So this line corresponds to 1 value. So this is the CDF of z. So now we can easily obtain the PDF of z by differentiating this function. So the PDF of z, you can see it will be equal to, so it is going to be 0 for z less than equal to 0. And in this range, we will have to differentiate this function. So let's rewrite this function over here. So it will be, in denominator it will be 6, and in numerator it will be z square plus z. So differentiation of this function will be 2z plus 1 divided by 6. So this is the PDF in this range for z greater than equal to 0 less than equal to 1. So it will be 2z plus 1 divided by 6 for z greater than equal to 0 less than equal to 1. And in this range, differentiation of this with respect to z will be 1 by 3. So it will be 1 by 3 for range z greater than equal to 1 less than equal to 3. And differentiation of this will be 0. So it will be 0 for z greater than equal to 3. So this is the PDF of z. You can plot this CDF and it will look like this. So this is our z-axis, and on this axis we will plot the PDF of z for sample value small z. So below 0, this PDF is 0. And when z lies between 0 to 1, it's a straight line with slope of 1 by 3. At z is equal to 0, its value is 1 by 6. At z is equal to 1, its value is 3 by 6. So it will be a straight line rising from 1 by 6 to 3 by 6. And for z between 1 to 3, it is constant and equal to 1 by 3. So this height is 1 by 3. And this maximum height is 1 by 2. This value here is 1 by 6. So this is the PDF of z. This value is 0, here it is 1, and this value is 3. So this is the answer to the part A of the question, in which we have to find the PDF and CDF of z. So now let's see the part B of the question. So I have copied here the PDF of z, and in part B they have asked about the probability that z is less than 2. So this will be equal to the area under PDF from 0 to 2. Or you can evaluate from the CDF of z for z is equal to 2. So putting here z is equal to 2, we will get this will be equal to 2 by 3. You can also get this answer by integrating the area under PDF from 0 to 2. That area will be this area, this entire area up to this line. So you can see we can break this into one trapezoid and one rectangle. So this area will be 1 by 2. Sum of parallel sides, that will be 1 by 6 plus 1 by 2 times the distance between them is 1, plus area of rectangle is, so that will be 1 into 1 by 3. That will be 1 by 3. So you can calculate it. It will be equal to 1 by 2 times this, the LCM is 6. So we will get 1 plus 3. So that will give us 4 by 6 plus 1 by 3. So that will give us 2. This is 1, this is 3, and this is again coming out to be 2 by 3. So next part is part C. In this we will have to find expectation of z. So that will be equal to integration from minus infinity to plus infinity, sample value small z, times the PDF of z, sample value small z, d of small z. So that will be equal to integration from 0 to 1 z times the PDF in this range is 2 times z plus 1 by 6 dz plus integration from 1 to 3 z, and PDF in this range for z is 1 by 3 d of z. So this will be equal to 1 by 6 integration of z square is z cube by 3 plus integration of z is z square by 2, limits 0 to 1 plus 1 by 3 integration of z is z square by 2. Lower limit is 1, upper limit is 3. So now putting upper and lower limits, we will get 1 by 6. So upper limit will give us 2 by 3 plus 1 by 2 minus lower limit, so all terms will be 0. So minus 0. Next we will get plus 1 by 6. Upper limit will give us 9 minus lower limit will give us 1. So 9 minus 1 will be 8. So multiply by 8. So this will be equal to 1 by 6 we can take common, and inside we will get LCM is 6, 4 plus 3 plus 48. So this will be equal to 55 by 36. So this is the expectation of Z. So next we will calculate variance of Z. So variance of Z is equal to expectation of Z square minus expectation of Z whole square. So this will be equal to expectation of Z square minus this value we have already calculated. It is 55 by 36 whole square. So now we will calculate expectation of Z square. So expectation of Z square will be equal to integration from minus infinity to plus infinity Z square times the PDF of Z dz. So this will be equal to integration Z square 0 to 1 2Z plus 1 by 6 dz plus limits 1 to 3 Z square. PDF value in this range is 1 by 3 dz. So this will be equal to 1 by 6 integration of Z cube will be Z raised to power 4 by 4 plus integration of Z square will be Z raised to power 3 by 3. So lower limit is 0, upper limit is 1. Plus next term will give us 1 by 3 times Z raised to power 3 by 3. Lower limit 1, upper limit 3. So this will cancel out and it will be equal to 1 by 6 times. Only upper limit will give us non-zero values. So we will get 1 by 2 plus 1 by 3. Lower limit will give us 0. So plus 1 by 9. Upper limit will give us 27 minus 1. It will be 26. So this will be equal to, first term we can write as 1 by 6 times this is 5 by 6. So it is 5 by 6 plus 29 by 9. So the LCM will be 36. In numerator we will get 5 plus 26 into 4. So that is 104. So this is equal to 109 by 36. So putting this expectation of Z square here, we will get the variance of Z is equal to 109 by 36 minus 55 by 36 whole square. So after calculation, this will give us 0.6936. So this is the variance of Z. There is another method to calculate the expectation of Z and expectation of Z square and variance of Z without calculating the PDF of Z. That method I will be discussing in next video. So I hope that you have learned everything that I have explained in this video. So if you have learned anything from this video, then please press that like button below this video and subscribe to my channel for more such videos in future also. Thank you all for watching this video.